Hi, good evening, everyone, and welcome to Demo Day for our second part-time immersive cohort, CCP2, here at Code Chrysalis. My name is Jay, and I'm an instructor here at Code Chrysalis. My colleague Bo and I have been working with the 6 individuals who will be presenting their products of their efforts and growth over the last 6 months. And of course, as you watch their projects, if you have any thoughts you'd like to share, we do invite you to tag us on social media. Before we begin, we'd like to say a huge thank you to all of our community members and our support members for helping our students throughout 2021. Before I hand it off to the students, I'd like to give you a small sneak peek at our journey as a team. After tonight, these students will have just completed 24 weeks of our part-time immersive program. Students have reviewed topics like data structures, recursion, and object-oriented programming principles in the beginning. Then we moved on to exploring each major component of a modern web application. The database, our backend server, and API, and our front-end clients. We then combined it all and began making full-stack applications individually and as a team. All of these culminating into the final presentation that you'll see at the end of tonight, their senior team capstone. And that represents a culmination of their progress and growth over the 6 months. And then without further ado, I'd like to introduce our first engineer. I'd like to introduce Ziza, who will be presenting her application, Genki Bot.
Thank you very much, Jay.
Before I hand the mic over to you, Ziza, just to let the audience know, this application was built during our Polyglottal Week event. Ziza's interest in Golang inspired her to build a Discord bot, and now I'll let you take over the rest of it.
So, good evening, guys. My name is Saiza Rivera, and I'm currently in the Philippines taking this part-time immersive course. So, I'm going to present to you tonight my polyglottal project, Go Genki Bot. Go Genki Bot is an experimental yet deployable Discord bot created while learning Golang. As Discord gained more popularity this pandemic, chatbots assist community members to attain their goals through reminders, gamification, or even host music in their voice channels. What a better way to contribute than developing a chatbot for them? And since I'd like to take some challenge, I chose Golang since it's one of the popular languages out there. And I'm curious also how it is used and be familiar also to the languages that I tried, like JavaScript and Python. No better way than actually doing it. This project it's still in its experimental stage, but I made sure that this can be deployed by anyone who is interested to use or contribute in this project. In this presentation, I will show you a demo of my chatbot, what tech stack I used, my challenges and learnings, and the plans for the project. So for the demo, I have a Discord server that I own, or even any Discord server that you have admin rights. So I have 3 basic functions for the Genki bot. First is a test connection command, which is hello world. And Genki bot would reply hi to anyone who called him through hello world. I also have a session command. It's stand up. And Genki bot would reply a set of questions for me to answer. Lastly, Genki bot has a reply feature. So anytime I will reply to him anything, so I'll try anything, or Genki bot would reply, got this, see you later, whoever replied to him. So for the tech stack, Genki Bot is created using Golang with the help of Discord Go, a package that provides Go interface to the Discord chat client API. And this is deployed to Heroku. You should also have a Discord server with admin permissions and developer mode enabled. Challenges and learnings. The ultimate challenge that I experience is that there is a lack of intermediate resources for Discord chatbots written in Go. I had a hard time looking for instructions that can teach me how the chatbot can do more complex interactions like responding to cumulative user engagements, how to connect the chatbot to a database, and also how to deploy the chatbot to the cloud properly. So after 2 weeks, I dive into different official documentations, like documentations for Golang itself, Discord Go, Discord Developer API, and also for Heroku for the deployment. I also learned understanding how these APIs interact with each other. And I really learned the value of documentations, regardless how small the project is, especially for future developers that would want to pick up a project that they would want to. I really learned this with this specific resource because it's the only resource that I started with, the only reliable research that I found in the internet. So I'm very grateful for this one. Plans. So my first plan is to connect it to the database for data persistence. This would simplify the features of the chatbot and create tutorials in creating Discord chatbots for Go, as I saw there is a great lack of it. And lastly, to expand the project by creating a web-based dashboard. So thank you very much. And this concludes my presentation. You may scan the following QR codes that leads to my GitHub repository for Go Genki Bot and my portfolio site. You may reach out to me through LinkedIn and Twitter also. Thank you for listening.
Awesome job, Ziza. Thank you very much. Please go check out Genki Bot if you'd like to contribute to this project and help also contribute to the Discord Golang community. Next, I'd like to introduce Gabe, who will be showing us his mobile-first application. So in week 15 of the course, Gabe identified an opportunity to employ his skills to better his community and developed his application in order to address this. I'll now pass the microphone over to Gabe, who will be telling us about his solo MVP, Festival Finder.
Thanks, Jay. Thank you, Jay. So, starting up my slide share. Okay, hi everyone, I'm Gabe, and tonight I'll be presenting my solo MVP, which I worked on during my time at Code Chrysalis. So, Festival Finder is an interactive map built using Firebase and Firestore, alongside React Google Maps library with the React JavaScript front-end framework. So, after an app overview, I'll show you a quick demo of my proof of concept, followed by a demonstration of my iterations and learnings from this project. So let's get started. So this is an app for local festivals. Imagine you attend the Shimokitazawa Candle Festival. You have a paper map, but it's dark out and you don't know where to go. This web application will guide you to participating businesses. The initial commits for my project included using Google Maps API to display shop locations, using geolocation to display the user's location. There's a feature for users to add their locations to their favorites using Firestore, as well as user login and sign up using Firebase Auth. Finally, the initial version of this app was hosted using Firebase hosting. The tech stack, as I just went over, uses Google Maps API for map and geolocation services, Firebase and Firestore for user auth and favorites, and React is the front-end framework built using JavaScript. Okay, so here's the demonstration of my initial state application. So what you see here is the authorization page where a user is able to sign in using Firebase Auth. So I've already created an account. Let's go ahead and sign in. Okay, so I'm not in Shimokitazawa right now, but I plugged this in here to give you a glimpse at what user location looks like within this app. So as you can see, upon selecting the candles, we see the participating shops. So let's see what happens when I click Take Me There. So the user is redirected to Google Maps, and in place of the favorites feature, I ended up opting for a visited locations feature. So the spirit of this was the idea of lighting the candles in this candle festival. So as you can see, the icon that I visited has been recolored red, and the same is true if I visit a different location. So that's all for the initial state app. Now let's look at the iterations and learnings for my project. So as you just saw, I replaced the favorites functionality with the visited functionality. So connecting to the Firestore database, I stored the location that the user has selected, organizers, to see if they were interested in the application. So it's a grassroots initiative, and of course they were interested and open to having contributors. So we ideated some new specific feature requests. So in the final state application, we've removed authentication for ease of use. In addition, we implemented landscape orientation mobile support, Netlify hosting for high traffic application use, and Japanese language support. So let's take a look at the current state of the deployed application. So what you see here is the final state application. As you can see, the database has been translated into Japanese, and there's no longer a visited functionality, as there's no user authentication to store that database. Instead, we simply have the navigation to Google Maps and some other links that the festival the festival organizers requested. So this links to the website and the voting page for your favorite candles. Okay. Oh, in addition to that, you can see that we've added landscape support for this application. So users can decide how they want to use the map on their phones. So for future features, I'd like to implement a candle icon numbering feature. So it shouldn't be too hard. I've already done the proof of concept, and it'll just make it clearer to the user which location they've selected. And this also lines up with how the map looks for the festival. So for learnings, this is a mobile-first web app. So styles are applied first to mobile devices. Responsive units such as percent, view height, and rem are used to style components and text. And portrait and landscape layout targeted styling is implemented using CSS media queries. So from this project, I learned that modern web apps make use of a lot of third-party services in order to build feature-rich applications. So this project in particular used Google Maps API and React Google Maps, as well as cloud hosting services such as Firebase Auth and Firehose. And before I say goodbye, I'd like to give you an open invitation to Komichi no Noel. So this is a local festival celebrating small shops and the local culture of Shimokitazawa. So it's on the 24th and 25th. It's a non-denominational, family-friendly event. And all you have to do is show up and look for the information booth at Shimokitazawa Station, where you'll find maps and QR codes with the links to the web application. So thank you so much for listening, and I look forward to seeing you there. Happy holidays.
Gabe, thank you very much for your presentation. Please do check out Gabe's application, and please do visit Kimochi no Noel this holiday season. I think one of the coolest parts about the job that I do is I get to work with people from different backgrounds and people with different priorities and things that they find, or different issues that they identify. The next person I'd like to introduce is Tom. And he has identified a problem that he and many families here in Tokyo experience. And he developed an application that we'll be looking at. This was built during our solo MVP project phase, so still in week 15. And I'll let Tom explain the concept of his idea more. So Tom, whenever you're ready, take it away.
Hello, everyone. I'm Tom, and I'd like to introduce my Kids Book Sharing Library app. So for today's presentation, the first thing I'll do is tell you a little about the goals for this project. Then I'll go into a quick demo of the project, and then I'd like to tell you a little bit about the tech stack. After that, I'll talk a little bit about the challenges and learnings from the project. And finally, I'll talk about a few next steps that I would like to implement in the future. So what are the goals for this project? Well, these days I read a lot of ebooks, but for my kids, I'd prefer them to read paper books because they already spend a lot of time on screens, and paper books are just much more fun for reading together. But as I live in Tokyo, getting hold of English kids books can be difficult or expensive, and we don't have easy access to libraries in English. So I wanted to make an app to help with that situation. So the idea of this application is parents can list the unwanted kids books that they no longer need, because as you know, kids grow up quickly and they always need new books. So other parents can look at a library of books that people are willing to share. And if they find a book that they would like for their kids, they can request to borrow it. Then the original owner of that book will see that request and the address information so that they can post that book to the new parents. So as we know, libraries are great, and the great thing about libraries is that they are open to everyone. And I think when I was in England, I made a huge amount of use of libraries. So I'm hoping this will allow people in Japan to do the same for English books. So now I'd like to do a quick demo. So here you can see two different instances of the app. One is running on the cloud and one is running locally, and two different users are signed into the application. So they can both see the library of books, but as you can see, some of the options that are available on the books are different, depending on whether they already have requested some of those books. So for example, the user on the right, Jay, maybe will decide that they want to add a book that they no longer need. For example, Mr. Tickle, which is by Roger Hargreaves and is in good condition. And this was a book that I loved as a kid. So as you can see, it has now been added to the application. And this My Books page shows each user an individual view of the books that they are offering, and also other books in different statuses. So on the left, user Tom should now be able to see that book. And if they think that that book would be good for their kids, they can request that book. And if they change their mind, they can always cancel the request. So now if we go to the My Books page, you can see this book is listed as a book that Tom has requested. And if we refresh this page, it's now listed as a book to be sent. And Tom's address is given to Jay, so Jay can post this book to him. After he posts it, he can mark it as sent. And on Tom's side, it's now in transit. And after he receives it, he can mark it as received. So this way, we can keep track of the books that we are offering or sending or waiting for or have received. There's also a sign out and sign in functionality. And that's the end of the demo. So I will go back to the presentation and Next, I'd like to tell you a little bit about the tech stack for this project. On the front end, I used React, which is a JavaScript front-end library. And I chose React because it's very fast and flexible, and it has a very large community. I also used React Router to handle different pages in the app and styled components to style the CSS and the layout. In the backend, I chose Firestore, which is a cloud-hosted NoSQL database, because it seemed a good fit for the data that I wanted to store. And it has a flexible structure, meaning I can add more information to books in the future without disrupting the existing books. Finally, I used Firebase Auth to manage the email login and logout and sign up, and also to handle things like password reset emails. And I chose this because it works well with Firestore. And I also used Firebase Deploy to deploy and host the application because it also worked well together. So a few of the challenges for this project. Learning to use Firebase and Firestore was a challenge at the beginning. One reason was that there was recently major changes to the Firestore API. So a lot of the documentation and answers that I could find online was using the older version. So I hope if I use Firestore or Firebase in the future, I'll be able to contribute to that and add a few more up-to-date answers. Another challenge was setting up authentication because I needed some pages to be available to unauthenticated users, but other pages to only be available to logged in users. And I needed to link those to the user so they could each see their own information. Finally, I needed to find a way to handle state and state changes across multiple pages. For example, if somebody adds a book on one page, it needs to show up in the library on the other page. And I didn't use a complex library like Redux for this project, as that seemed like overkill. So I had to manage a few cases of that myself. As for learnings, initially, this was my first time building a full stack application, and we only had 1 week part-time to do it. So that seemed like a huge challenge, but you can achieve a lot if you set your mind to it. One way I did this was by getting the basics working first. I made simple front-end components, and I mocked up back-end API calls so that I could get those working. And then when the backend came online, those front-end components could connect to the backend. The other thing I learned a lot about was using cloud services for deployment, authorization, and storage, and also connecting those together. And I learned that using these kind of features allows us to roll out applications much more quickly. So the last thing I'd like to talk about is some steps for the future. One thing I'd like to do is improve the cover image API so that users can, if the cover image that comes up is not correct, they can select an alternative, and also to cache images in the database in base64 so that I can reduce the number of API calls. I'd also like to optimize the database for larger libraries with features like pagination. And I'd like to improve the CSS styling and add a few extra features like rating users to improve the trustworthiness of the application. So this is our team, which is me, as this was a solo project. And at the bottom, you have a few links if you would like to contact me on Twitter, GitHub, or LinkedIn. And please check out the app. You can see the link to the code at the top, and the link underneath has a link to the web app, which is deployed on Google Cloud Hosting. Finally, don't forget to read books, especially with your kids if you had them, because reading books is great. And thanks for listening. And I hope you enjoyed the presentation.
Tom, thank you very much, Tom. Awesome work. So as engineers, we have interesting skills that on a day-to-day, we try to solve problems. The next application that I'd like to introduce, though, is hopefully conveys to you guys that sometimes we use our skills just to have fun. And so the next person I'd like to introduce is Fumi, who will be presenting his Doraemon API that hopefully inspires you to, when you're coding, bring out your inner child as well and just have fun with coding. So Fumi, whenever you're ready, please take it away.
Thank you, Jay. Hi, everyone. Tonight, I would like to show you my Doraemon API, or in short term, Dora API. So what is it? So basically, this is like a Pokemon API, if you're familiar with playing around with the data in API, but I want to make it for the Doraemon gadgets. So simply put, this is a REST API-based Doraemon gadget database with full cloud functionality to it. So next, I would like to have a quick introduction to the tech stack I used. So the programming language I primarily used in this project was TypeScript. It was really great to learn about strong typing, and I had fun with it as well. For the front end, I used the React, and from the backend server, I use the Node.js, and the database, it is PostgreSQL. Next up, I would like to show you a quick demo of this project and show you how it works. So I hope you see my Google Chrome. Basically, this is the web page, and here.
Sorry, Fumi, your screen is still showing the demo.
Oh, my. Okay. All right. Okay, so I hope it's showing okay now. So right now I am showing the front page of my Doraemon API. So basically, in the middle I have a UI which you can interact with the data that you get returned from the database. So this is just a simple proof of concept. So all the design is not so great. However, it does have a full functionality of to interact with the database. So if I hit with this endpoint gadget, then all gadget basically returns you all the gadget data that's in the database, in the Postgres database, and you can scroll up and down. So let's say I have another cool gadget I would like to store in the database. So basically, I just need to change the endpoint to the post, and let's start change the endpoint again. Now, for this, anything inside the frame, I can just reset it. So let's say I want to post a new gadget. Let's say gadget name and several fields I have to type. So one gadget type, and who is the owner, and who are the users, which at this point it's still called characters. Now, what's the name of the gadget? Let's say this is cool gadget. And what's the type? It's cool gadget type. And who is the owner? It's, let's say I give ID number 1. It's a Doraemon. And who are the users or the characters who used it? So in this case, I could give array of ID of the characters. If you can see the doc, you can actually go to the doc and check more of those specifications. Let's say Doraemon and Nobita is the users. So save that. And if you hit submit, now data has been submitted. At the time of when I created JSON, I put the numbers for the owner and characters. But if the post is successful, you can actually see the actual data of the characters. So here you see Doraemon. I don't know his last name, so I just put it no. Age, since he's from future, it's a -91 age. And you can also reset again to reset the data. So let me go back to the slide right now. I think I have to reshare. So next, I would like to talk about challenges and learnings. So most of the tech stack, especially the TypeScript, was very first time I touch it. So I had a little bit of learning curve to get used to it. But now, after experiencing that, I really like the type checking and how editors can suggest certain methods attached to the object. That's very great functionality. So I'm prone to type checking and sort of moving away from JavaScript right now. ORM and seeding was difficult first, but it was the same as TypeScript, just made of getting used to it. And last thing I learned was to make something that works and refactor later. Basically, anything make it work first is one of the hardest thing in the coding. So, and refactor is something I felt a little bit easier once everything starts working. So future plan, what is it? So future plan is I would like to scrape more data. So I could make the database as large as Pocket API and make this project to be open source so people can work on this and play around with it. And also add a GraphQL endpoint to it. And finally, add authentication. So it allows users only who are authenticated to add a post new data, delete new data, and actually modify with a patch endpoint. So here is end of my presentation, and here are a list of channels you can reach out to me. Thank you very much for listening, and have a good night.
Thank you very much, Fumi. Next, I'd like to introduce John. And so something that's interesting in both the part-time immersive and the full-time immersive is just the diversity of people who come through the course in terms of their backgrounds. John's currently in Shiga Prefecture, where he's a mechatronics engineer. And so John decided to take his polyglottal project in a different direction by pursuing his passion of combining code and hardware. He built the following demonstration you'll see during week 17, which was our polyglottal week. John, whenever you're ready, feel free to take it away.
All right. Thank you very much, Jay, for the wonderful introduction. Hello, everyone. Thank you very much for joining us this evening. Today, I would like to introduce my Polyglottal Week project, the DC Motor Monitor. My name is John, and I'm a mechatronics engineer with an always growing passion for building new things. So let's get started, shall we? One of the things you might be wondering is, how did this idea come up? So far during the course, I have been mainly focused on web-based applications. So for this time, I would like to move something in the physical space from the internet. Based on that thought, this project came up. It is intended to be a motor control and monitor system with an interface connected to the internet. Since it was my first time tackling this kind of challenge, I decided to keep it simple. A simple device, a simple control method, and a simple interface. The idea is for this to be a start point for more complex applications. About the technologies I used, they can be divided into 4 groups. The control system was provided by the Arduino Motor Shield Red 3, specialized for DC voltage-driven devices. Our real-world actuator is, as the name implies, a DC motor with encoder for position reading. The interface was created in Java, making use of the powerful capabilities of the Java Swing library and the Eclipse development environment. And for the web server, we use the Arduino Uno Wi-Fi functionalities to create a simple API with a couple endpoints. I would like to also talk a little bit about the development cycle for this project. Since the technologies involved are not all web-based, I could not use the same approach I used for the other projects during the course. For this occasion, I had to write some code for the Arduino, verify if the output were the expected in the physical devices, and finally, check if I could recreate those results from my web-based interface. Looping through these 3 steps was crucial for making this project reality. That being said, it is demo time. Because of the nature of this project, I have prepared a video showing our results, so please take a look.
Thank you very much for your attention. This is the demonstration of my project, the DC Motor Monitor version 1.0. As you can see here, we have the Arduino Uno with the Arduino Shield already mounted and connected. And here, we can see our LCD display that shows the local IP address of our device and the current motor position. Since we just started the system, it displays 0. And here, we can see our physical device, a gearbox DC motor with encoder for position reading. You can also see our Java interface in the lower corner of the video. Let's start by establishing connection, shall we? So the first step is to type the same IP address that is shown in the LCD display. That was done beforehand. And after I click connect, we can now see that we're making calls to that same IP address. If I press right, the motor starts rotating clockwise and the position starts increasing on the LCD display. Similarly, if I press left, the motor starts rotating counterclockwise and the position decreases. If I press stop, the motor stops and the IP address is again displayed. One unexpected result is the smoothness of the transition between one state and the other. If I keep alternating the rotations, we can see that we actually have a very good response time, and that's something we're very happy with. That will be the end of my demonstration. Thank you very much for watching.
Welcome back, everyone. For the challenges of this project, documentation was definitely one of them. As a first-timer, making research for these technologies took a considerable effort. Also, since we are keeping things simple, it is easy to think of the project as a whole. Properly dividing it into parts was very important for our development process. Another challenge was also the setup and usage of several IDEs. Usually, we can do almost everything from VS Code having the right extensions. But for this case, I needed to set up the Arduino software IDE because it's the easiest, if not the only way to send your code to the Arduino. And of course, it is also easier to develop a Java application in its dedicated Eclipse IDE environment. Finally, I also learned about safety. Originally, I was planning to use a 6S LiPo battery because of the power it can deliver and having in mind this project's growth possibilities. However, since it also presents a potential risk of explosion and fire, I decided to go for a regular 7-volt consent-connected voltage source. What I learned while building this project is that systems might be complex, but if they have a simple interface, it is easy to make them interact with other systems. Connecting worlds this way, you can create multidisciplinary amazing applications. I also learned a lot about trade-offs. I would have liked to make the physical device a little bit more complex, but I also had to keep in balance issues like the money already invested, the time of the design process, and the already available hardware. So I decided to pin it as a future feature. As final words, I would like to add that even when this project is simple in shape, it is just the tip of the iceberg. It came to be a real-world device controlled by the user through the internet, and we strongly believe it has all the ingredients necessary for growing integrated applications. That would be everything from my side. Thank you very much for listening. You can check the repository in the description below, and if you have any questions, please do not hesitate to contact me. Hope you'll be having a good time.
John, thank you very much for your science class experiment and telling us all the cool stuff that we can do with code, not just in web applications. Certainly last but not least, I'd like to introduce Romain, who during his Polyglottal week built the next project. Romain was able to use his technical abilities to solve a problem that he had in his day-to-day life, built an initial prototype and continued to iterate to what you will see tonight. So now Romain, wrap us up for our solo projects.
Thank you, Jay. So for my display tonight, I will display the project I made during Polyglottal week. It's a stock chart app for the Jamaica Stock Exchange. So this app, it scrapes data from the JSE's website and charts it. Yes, and I decided to make this app because I was really busy during the course, so I didn't have the time to go to their JSE website and go through all the pages there and get the data that I needed. So I thought it would be easier to create my own source for that data so I could quickly view the performance of the market. Now my demo. So this is what I ended up with. This is version 2. And as you can see, I deployed it on my domain, and it's live on the internet right now. And so you can choose the companies here, and it will reload the charts with the latest data for that company. Also, there is a blurb at the bottom, which gives you a little information about what the company does. And you can also put overlays and oscillators over the data to get better understanding of what's happening. So yeah, you could also, if you hover over the charts, you get more fine-tuned data, the opening, the high, low, the close, the volume, and the data from the oscillators and the overlays. So the tech stack used in version 2 of my app is Python and HTML. And initially, in version 1, I had used Python with Flask, but I realized that was over engineering, and I really didn't need to have a server to host the website. A static file was enough. The data is stored in MongoDB, and I deployed on AWS using S3 and CloudFront. Challenges. So I had a really difficult challenge of authenticating users programmatically. I really struggled with that problem for a long time, but I ended up with a semi-automatic authentication process, which I think works for my needs. State management. I coded this website in vanilla HTML and JavaScript, and the JavaScript is within the HTML. And I had to manage the states, for example, if the overlays were on or off, or which company was currently selected. And that was a real challenge for me. The documentation on the charting software also posed a challenge. It took me a while to parse how to create the chart using that software and deploying. I haven't used AWS in a while, so it took me a while to get back to understanding or in the flow of using it. So that was a bit of a challenge as well. Learnings. I learned a lot about cookie-based authentication and JWT. I learned a lot more about AWS that I didn't even know. It's always changing. So when I tried to use it again after almost a year of not using it, I had to relearn a lot of things. And manipulating scraped data. The extraction, transformation, and loading of the data was really fun for me. I had a good time gathering the data, and yeah, that was a lot of fun. For the future, I'd like to use a web function to initiate data scraping, maybe Lambda or something like that, so that I could make the process fully automatic and display other information about the stock. Currently, I'm only displaying the OHLC prices and volume, along with a little blurb about the company. I'd like to display other information, for example, the financial, what quarter the company is in, when's the next financial report due, and things like that. And finally, scraping PDFs. There's a lot of data within the financial documents of each company, and I really love to scrape the PDFs so that I can create some fundamental indicator for each company. And that is it for my presentation. Thank you for listening. You can contact me at these following places. And if you want, you can also view and use the app online by scanning the QR code or entering this URL. Thank you.
Romain, excellent presentation, and thank you for wrapping up our solo project section of the demo night tonight. These were projects that were created before the students developed their senior project tonight, and they've come a long way. So without further ado, I'd like to introduce Team Yacht, who will demonstrate their application Emina and show us what 24 weeks of learning and 6 weeks of concentrated project development can produce here at Code Chrysalis. So I think, Gabe, you're going to be the opening words, correct?
That's right. Thanks, Jay.
Cool. So when your team is ready, everyone turn on your microphones and your cameras. And I'll let you take it away.
Alrighty. Okay. Hi, everyone. I'm Gabe, and on behalf of yet another coding team, it's my pleasure to introduce Emina, our pop culture tourism app. So, our application introduces travelers to their favorite Japanese pop culture locations in real life, giving users the ability to self-curate the travel experience of their dreams. So, first things first, let's meet the team. On our app's front end, I worked primarily on user interface and experience, fetching and displaying information in an intuitive layout, from shared photos to search results from our database. I'll pass it off to our wonderful tech lead, Saiza, to introduce herself and tell us about her role on yet another coding team.
Thank you very much, Gabe. I'm Saiza, and I'm the tech lead for Emina. I manage the team from project ideation, development, and up to release. For the front end, I am responsible for the front end code maintenance, UI theming, and setting up the offline data storage. I also handle the Google Play Store deployment of our application. And I'll introduce you to Tom.
Hi everyone, I'm Tom, and on the front end, I worked on setting up the initial navigation for the app, also setting up the data connections to the backend, and I worked on the authorization with the backend team.
Hello, everyone. My name is John Fernandez, and I work mainly on the machine learning recommender engine prototype. Now, please allow me to introduce Fumi.
Thank you, John. My name is Sumi. I primarily worked on the infrastructure side, setting up CI/CD, setting up infrastructure in Google Cloud Storage, as well as writing web servers for the backend. Next, I would like to introduce Romain and what was his role in this backend team.
Thanks for me. So I'm Romain, and I mostly worked on gathering data and loading it into the database, and also creating endpoints to pass that information to the front end, and authorization for the app. Back to Gabe.
Okay, thanks everyone. So let's take a look at what opportunities our team works to identify during the ideation process. So our team identified an unmet want among foreign tourists to view and visit locations from Japanese pop culture. Currently, there's no easy way to search locations from pop culture media. There's also a lack of consolidated English resources. So taking a look at market validation, pop culture tourism accounts for almost 5% of Japan's foreign tourism annually. A major motivation for this subset of visitors is traveling to real-life pop culture locations. So some additional product research. So we found some English curation sites, but they were web-based, lacking portability, and no search features were available. In addition to this, app-based solutions were not in English, so it was difficult for foreign tourists to access these different applications. Finally, we couldn't find any user-generated content in any of these solutions, so that was our driving point. So let's take a look at our approach. How did we address these unmet needs? Well, our pop culture tourism app consists of media, a database of anime, books, and movies, which can be searched So you can search for real-life locations by media. In addition, we have photo sharing, so uploading user content and sharing your favorite moments with your friends. And finally, our app is English-based, so we have English language support for foreign tourists. So just to wrap things up here, Emina's core competencies consist of its convenience, so it's a smartphone-based app, you can take it anywhere. Its language, oriented towards English speakers, and it's being a one-stop solution. So it's an interactive database with user content. Now let's take a look at Sammy. Our team wanted to maintain a strong sense of our core user base throughout the development process. To ensure this, we ideated a user persona at the start of our project's inception. Through the eyes of Sammy, we were able to explore the goals and characteristics of our users. With that, I'd like to introduce Sammy. A 23-year-old recent graduate from the United States, Sammy is an English speaker looking forward to visiting Japan. Sammy's primary goal is to visit locations from their favorite anime in real life. A fan of online forums and photo sharing apps like Instagram, Sammy wants to catalog their journey with pictures they can share with their friends. In order to demonstrate the solution our team devised, I'll hand it off to Saiza for an overview of Emina's core functionalities.
Thank you very much, Gabe. So for the demo, I'll take you to our emulator. So once you open our app, you'll be welcome to our home screen with a search bar on top and a list of content inside. So right now, I'd like to search for the anime Your Name, which I have already typed here. Search. It will take you to our search page with your name as the result. If clicking on it will give you more details about the media and the list of locations that is available in our database. So right now, I'd like to go through Suga Shrine steps. And in this page, will give you a view of the actual location and also the location in the anime with a few description of that location. Scrolling down, we'll have a Google map here of the location and the photo gallery of user-generated content. Clicking also on the Google map would lead you opening the Google map itself, so it can help you go to the actual location. Going back, so one of our main function is to be able to save a location to our database. So going to the Save tab will have your list of locations that you already like, and over here we have Sugar Shrine steps. Clicking on it again, I'd like to add a photo. You can choose a photo. I can also take a photo. Have photo here. I'll just type yay, upload it. In a few seconds, your photo shows up. I can also view my photos in the profile gallery of my own. Clicking on it, I can also scroll into other photos that I have posted. And we also have a delete function whenever if you want to take down your post. So that ends my demo. I'd like to hand over this to Romain to present about our tech stack.
Thank you, Saiza. So for our tech stack, on the front end, we used React Native and JavaScript as the language and framework, main language and framework. And we chose React Native because it offers cross-platform. You could code one code base and use it in cross-platform. So right now our app is Android only, but in the future we could deploy on iOS. Native base and React navigation, we use those to create the navigation functionalities and do theming and Google Maps to create the map to the location. Next. On the back end, the language we used was Python with the Flask framework. And database, we store all our user information, location information, media information in MongoDB. And the storage of photos for storing photos, we use cloud storage, Google Cloud Storage. And authentication, we use Realm, MongoDB Realm, and JWT. A recommendation engine, for a recommendation engine, we use TensorFlow. And for infrastructure, we use Docker to containerize our code on the back end and deploy it to Google Cloud. And for data, we use the movie database and Google Places. And finally, we deployed our app on the Google Play Store. So next, I would like to hand over to Tom, who will speak about the front-end challenges and learnings.
Hello, everyone. So I'd like to tell you a little about the challenges and things we learned on the front end. So one of the first challenges we faced was setting up Android Studio and the Android emulator, which can be rather tricky and can take up quite a lot of resources. Another initial challenge we had was planning the application features and the layout, and deciding on the user persona. One of the main challenges we faced was managing the state of the data, both locally on the phone and managing changes across different app screens, and also syncing with the remote database and trying to minimize API calls while also keeping the data up to date. And I'll tell you a little bit more about that now. So in addition to sign up, sign in, and sign out, we also used local secure storage to store authorization tokens so that we could access the endpoints on the back end securely. Our app also will have basic offline functionality, so you can access your saved locations even if you go to the destination and you don't have a network connection. So to implement that, we stored the saved locations in local async storage. Also, we used use state or use context to store other in-memory data from API endpoints that needed to be shared across the application. And finally, we used features such as use focus effect to update the refresh of the data when it changed across screens. So talking about front-end learnings, we learned a lot about rapid prototyping, and I'll talk about that in a moment. We also learned to use several new libraries, such as React Native and React Navigation, and also Native Base for styling. One very useful thing we learned was working together as a team on a more complex Git repository with multiple feature branches and implementing things such as code reviews and issue tracking. And finally, both on the front end and the back end, we learned a lot about generating JWT tokens and passing those between the front end and the back end to ensure secure routes. So in terms of rapid prototyping, one thing we did was brainstorm early mockups for the application using Figma, and you can see a few of those here. We did this bearing in mind our user Sammy and their goals and behaviors. And we mostly finished pretty close to these initial mockups, although we did change things where we came across new goals or new needs. So now I would like to hand over to Fumi, who will talk a little about the backend.
Thank you, Tom. From here on, I'd like to talk about backend trends and learnings. So several challenges and learnings we had. First one was about infra setup. So we set up our infrastructure in Google Cloud, as well as setting up the CI/CD pipeline was done in using a GitHub Actions. Now, the one of the bottleneck was in the early, especially the early stage of the project, was infrastructure. And as a team, we didn't want this to be bottlenecking entire project. So we had to quickly set up the infrastructure to be ready for other team members to use. That means the development of the application. But from here, with what we learned was quite useful. A lot of infrastructure setup can be done automated or can be ported in the code. So eventually, I think in terms of reusability of sort of setting up process and reducing the time for that, we realize it's better to turn that infrastructure setup into the code, such using frameworks such as Terraform. Data collection. So this was a major, one of the major blocking, especially when most of the data was collected through, we didn't have a big database. So like we had to collect it through some personal blogs. So a lot of data collection was done manually, but I think once we find a good website that has a lot of data, I think Romain can handle the scraping website and increase our contents. Thirdly, we learned a lot about Google Cloud Billing, especially how much resources need to be used and for the servers and backend databases. For the photo storage on the Google Cloud Storage. So what we learned is that we need to have a good monitoring system for how much invoices we get end of the month. And finally, it's about Flask Server and MongoDB. This was something new for the team members in the backend team. So learning these, we had a bit of a learning curve, but it was something we just got used to it. And now we were able to successfully develop a good backend server. Now we'd like to have John to talk about the future features of our application.
Thank you very much, Fumin, and hello again, everyone. Now I will introduce to you some of the future features we have in mind for our application: rate location, view other user profiles, and the recommender engine. For rate location, we intend to implement a 5-star ranking system widely used in several well-known applications. We believe that it's very important to get to know our users as much as possible. So the objective is to obtain a more detailed user's preference data that we can collect and process for other features usage. But we will talk about that in a minute. For viewing other user profiles, we intend to implement the capabilities of searching and following some other user that might have caught your eye while navigating the app. The main idea behind this feature is to encourage the user to form a community with people with similar interests or preferences. Traveling alone might be fun, but traveling with friends is a blast, and that's why we consider this feature a worthy addition to our application. Now, for the recommender engine, I would like to go a little bit deeper because it is a feature that we actually have as a first standalone prototype. I would like to start explaining briefly and in simple words what a recommender engine is. You might have seen this already in very well-known applications such as Netflix or Amazon. It is a system whose objective is to match users or potential customers with goods or services they might like. It gets to know you better through the likes and ratings you and other users input into it. So it considers your tastes during calculation and intersects them with a variety of product profiles. Illustratively speaking, it might look a little bit like in this image. For this feature, we made use of TensorFlow Core and its library TensorFlow Recommenders, especially designed with high-level functionalities for building these kind of systems. We also used TensorFlow datasets for creating and modifying mock data. This data attempts to emulate what real user input data might look like. To put it simple, our recommender engine selects a bunch of possible candidates from our dataset and then sorts them accordingly to the affinity with the user. As you may see in the following pictures, we have the prediction for 2 different users. This is the first one. The selected candidates might look a little bit random, but if you look closer, you might notice some similarities between them. One user seems to be more romantic movies oriented, since the other user might have preference for suspense movies. One of the strong points of these kind of systems is that it will evolve with time as it gets more data from the user, so the recommendation will adapt to the ever-changing market. Before we finish, I just would like to add that we are looking forward to hearing from you. If you could download and try our app, we will be more than happy to hear your feedback. We proudly share with you this QR code to our deployment in Google Play Store. That will be everything from our side. We are yet another coding team, and this was our application, Emina. Thank you very much for listening. And if you have any questions, please feel free to contact us. Once again, thank you very much and have a great evening.
Thank you very much, CCP2. I hope that you guys are very proud of the application that you guys built tonight and the applications that you've built individually as well. As your instructor, I'm incredibly proud to have worked with a team of empathetic, solution-minded, autonomous, and honestly just fun engineers. With that said, I have some unfortunate news for you. Your journey still continues on after tonight. Come next year, these engineers will be job hunting and their journey is not over. So if you see them out in the wild, I think you'll also find that any one of these students brings a lot of heart and a lot of effort into the projects that they work on. So I have a couple announcements that I have to make. So first, if you're interested in joining the Immersive Full-Time program, the deadline, it begins on March 28th, and the suggested deadline is January 31st. Final deadline is February 21st, and this is our 12-week full-stack engineering track. And it runs Monday to Friday, 9 to 6 p.m. Please visit the website for more information. The next is if you're interested in joining the Immersive Part-Time, just like my students tonight, it begins on April 19th. The suggested deadline is February 21st with a final deadline of March 14th. It's a 25-week full-stack engineering course, and our class times, and the class times of the students that you saw tonight is from 7 to 10 p.m. JST, and then Saturdays from 10 a.m. to 5 p.m. And again, there's more information on our website for that program as well. If you're new to coding, if hopefully the projects that you've seen tonight inspired you to think that maybe I can make an application or a solution for a family member, a community that I live in, or just something fun for myself. If you're interested in learning the fundamentals of coding, check out our Foundations program. We have a cohort starting on January 10th, 2022. The final deadline for applying is December 23rd. And it's a 10 weeks intro to programming course for non-engineers and complete beginners. The courses meet Tuesday through Thursday, 7 to 10 JST, and Saturdays 9 to 4 p.m. And with that, I'd just like to leave off for everyone. Have a happy holidays from everyone here at Code Chrysalis to you. See ya.